Chapter 6 AP Environmental is going to deal with weather, climate, and biomes. I'm going to lecture mainly on weather and climate, and we'll do an activity in class that covers. So let's dive into this. First of all, the difference between weather and climate. Weather, think as a daily occurrence. It can happen over a couple hours. It can happen over a 24-hour period, maybe a couple days, and that's about it. Whereas climate is long-term, looking at years, looking at decades, looking even at centuries. We've got lots of years going back into the 1800s of records that prove different climate patterns and relate to global warming that we're going to talk about down the road and that. So it's really well researched, but it's really hard to tell what our future climate's going to be. Couple variables that really come into play with weather. First of all, warm fronts and cold fronts. We've all seen these in our multiple changing climates of Wisconsin, or I should say weather patterns of Wisconsin. First of all, warm front, and you really have to think of this in terms of molecules in the air. Remember back to chemistry that the closer molecules are together, the cooler they are. And remember, molecules as they rise because they are being heated. So think of that, and as they rise, they're going further apart. A warm front, you can see in the picture right here, goes up and over a cold front. The reason it does, again, is because the warm air molecules are further spaced out. Warm air rises. What oftentimes happens with this is we get cloudy, rainy days. Think of the spring when we get warm air coming in from the western part of the United States and the southern part of the United States. What happens is it gets a little rainy, but again, we get a little bit warmer climate because it pushes that air out, or a little bit warmer weather, I should say. A cold front is the opposite. A cold front is when we have an advancing mass of cold air that stays close to the ground. So if this is the ground level right here, cold air is going to come in very low to the ground because those molecules are close together, and of course cold air sinks. Oftentimes if we have that advancing cold front, and ours generally here come from Canada, we get thunderstorms, very high winds, eventually ending up with cooler, clear weather. Jet streams are very important to talk about that relate to weather also. They tend to be at the top of the troposphere, and remember, all of our weather occurs in our troposphere, which is about from sea level up about 5 miles. Think of jet streams as our jet stream goes from west to east in the United States. Our weather patterns can be really based on what's occurring in northern Iowa, what's happening in Madison. Generally what's going there is kind of shifting in this regard. And a lot of that's pushed by these jet streams. It has a strong influence on weather patterns. Think of the jet stream also if you've ever flown from Chicago, for example, to London. You go up and over the polar regions, not only because the atmosphere is thinner there, thus less molecules, thus less gas, and faster for the airplane, but also what happens is you're riding the jet stream over. Even if you fly out to Arizona or California, it comes into play too, because as you fly out there, you're going to be bucking the wind, which means that we have more resistance, which means we use more gas. When you come back from a flight from Arizona or California, it tends to be about a half hour quicker, and they use less gas because they're catching the tailwinds. So again, think of the molecules as we look at air pressure. Air pressure is when we have zillions of tiny molecules. Nitrogen makes up 78% of our atmosphere, oxygen 21%. They're zipping around, flying at high speeds, bouncing off of each other. Atmospheric pressure, of course, is greater near the Earth's surface. So think about all those molecules are more dense near the Earth's surface, and the reason is because gravity pulls them down. High pressure systems contain cool, dense air that warms as it descends. I'll show you a picture of this in a little bit, generally associated with fair weather. Low pressure systems produce cloudy, stormy weather. Oftentimes with that, the center of the low rises. If condensation nuclei are present, rain will be produced. Condensation nuclei are any little particles in the air that water can hold on to. People around here tend to burn their leaves in the spring or in the fall even. What happens is that smoke goes up into the atmosphere, and it's a little tiny molecule, or particle I should say, that actually water can hold on to. If we don't have condensation nuclei, clouds can't even form. So here's an example of a high pressure system. You can see out in the Midwest we've got a high pressure system right here and a high pressure system there. What it looks like kind of on a side view is molecules are moving down. They are converging down. So they're pushing down. More molecules are coming down toward the Earth, and it's producing a high pressure system. Remember, cool, dense air is being pulled down, and it tends to, as it descends, warm up a little bit because the Earth tends to be a little bit warmer and hold heat very well, and we generally get fair weather. And you can see that clearly on the map here. Not a lot of rain going on in this region. The opposite is with the low pressure system. We've got a low pressure system moving through right here. You can see in the great state of Wisconsin probably getting a little rain slash snow, or even just a little straight up snow on the tail end of it. But a low pressure system, looking at it, is the molecules are actually going up, and it's creating more molecules going up, less molecules down here, so there's a low pressure system. Generally associated with a low pressure system, as this picture shows, is stormy weather. And again, if that condensation nuclei is there only. If it's not, we're not going to get stormy weather. If you have a hard time remembering low pressure systems, high pressure systems, particularly what the weather is going to be like, think of this map. High pressure systems, really nice weather. Low pressure systems, of course, kind of a nasty weather. Extreme weather, of course, we know this all well because we do tornado drills in the springtime. Generally what happens, tornadoes form over land, of course, dry funnel-shaped clouds. What happens in this region is we get cold air that comes down in the spring from Canada yet, but we get warm, moist air that generally comes up from the Gulf of Mexico. Again, spring is the time of the year when we have to worry about tornadoes, actually all the time, but generally spring. What happens with this is a large, warm air mass moves rapidly over more dense mass of cold air, rapidly rising, causing vertical convection that suck air upward. That's the technical definition. Basically, and this is the state of Wisconsin, of course, us being in this region, we get that cold air advancing down from Canada, and we get that warm, moist air coming up from the Gulf of Mexico, and they're generally moving at a pretty high rate. So what happens is they come together and they start forming convection cells like this, and they can form tornadoes. Now what's really interesting is in the state of Wisconsin, we kind of almost have like a micro tornado alley in that region that I just drew, kind of Dodge County, Fond du Lac, because that tends to be where those pressure systems come together. Of course, we are not immune to them down in this region, but they do happen there. So tropical cyclones are another issue. In the Atlantic, we call them hurricanes. In the Pacific, we call them typhoons. Hurricane season tends to be July through about November in Florida region and Texas region. They worry about it. Obviously, Louisiana, all those areas. That's why if you ever want to go to Disney, it's really cheap to go in October because that's hurricane season. These are cyclones that form over warm ocean waters. We're actually seeing, as a result of global warming, not more tornadoes rather, but more severe, not tornadoes rather, we're seeing more advanced hurricane systems. We're not getting more as in number-wise of hurricanes, but they are much more severe because the water's warming, thus the molecules are moving faster, thus they are getting much more severe, like in Hurricane Katrina, which we'll talk about. These are formed by low-pressure cells of air moving over warm tropical air seas, and as you've probably seen on TV, we can actually track these things really well. The problem with hurricanes, they injure people, damage property. The good thing is they do flush out excessive nutrients from land runoff, a lot of dead seagrass, rotting vegetation from bays and marshes. So what we saw during Hurricane Katrina down in the Gulf of Mexico with New Orleans as it came in, and it washed a lot of that dead and dying debris back out into the ocean, and then it actually, due to succession, allowed new plants to grow. But overall, of course, it can take people's lives, so it's not real pleasant. It does promote increase in shellfish, fish, and algal growth too, because it gets rid of the old stuff. Just a little diagram of it. Of course, this is a little hurricane. We'll take a look at some of these a little bit more in class, but we get those convection currents occurring, and of course one unique thing is right in the middle we have the eye of the storm, which is totally calm. Storm chasers actually fly into these things to research them and to see actually what's causing them. Unfortunately, it's not one of those really things that we can prevent. All right, that's it for the first lecture. We'll continue on with Chapter 6 in a bit.